learner's model, one of the beams will be electrons and the other one will be protons. So they're not, in his model, not mixed. What we actually detect, it's open to debate whether that is true or not.
I would think both of the beams would have to have both electrons and protons, because you have to have a circuit in order for that thing to be flowing in the first place. You need to have a current going in both directions. And so, in order to see things like synchrotron radiation coming out of them, you would need to have both, no?
No. To see synchrotron radiation, you just need to have the particles effectively accelerating in a curve. That's what produces it's a little bบmore complicated than that, because you need magnetic fields as well. And don't forget that Lerner produced these beams in his lab. So he produced, a microscopic version of this. And in that process, he saw different beams. And he analyzed the difference between the electron beam and the proton beam. So, the reason it doesn't require a circuit is because in that model, it's effectively just pushing it out. Effectively what happens is
I see what you're saying.
Compresses. You get the twisting vortex filaments, which then compress the magnetic energy into the plasmoid, and effectively that energy is I think he says it's multiplied by, I think it's 1 million or 100 million or something like that, into a really small space, and that energy is then released through these pulsing beams. So effectively what it's doing is effectively destroying itself. So in his model, the plasmoid decays over time, and if you look at his model for the active galactic nuclei, the same thing applies. And what's interesting about that is, because I've often wondered, what keeps a plasmoid going? And in his model, he says, well, it doesn't. It effectively dies, and then the process repeats. So you have the same thing starting up again. More gas falls in, twisting vortex filaments, forming a new plasmoid, and that then creates new beams that last for a certain period of time.
Okay, all right. So, yeah, this still sounds pretty in line with what we're talking about here. Is there a screen share feature on the Skype?
Yes, yes.
Because I've never tried to record Skype before with this software. I'm hoping this will work where both of our faces are on the screen here. If I could share my screen with you, it would be perfect. Oh, there it is. I see the button for it.
Yeah.
You see it now?
No, I don't even see you. I just see me.
I pressed
me. Me.
You mean the Foo Fighters song? All right. So you can only see yourself. You don't see a white screen or a whiteboard.
No, I see your little icon. Oh. You and your bird.
All right, hold on. Oh wait. Now, does that change anything? Hold on. Maybe I can. Maybe this will work. Hold on. Let me see if this works. I'm going to try to share just the application window. Let's see if that works.
Yeah.
Now you see you see a whiteboard?
I do, yes.
Oh, excellent. Okay, so here's this is the Gong 2 image of the sun, right? So I'm just going to take, doesn't really matter what color, right? The sun has a field that comes out of it that looks a bit like this. Yeah. I'd imagine. And, there's a kind of a persistent coronal hole that comes out of this thing. And, of course, one on the opposite side. There's probably currents traveling in both directions. You would imagine this is kind of like a fractal of the Earth's poles, right?
To an extent, yeah.
So wouldn't it be plausible to try to look for a signal in the sun's behavior and or where these things point, as opposed to trying to look at the what do you call it? The local chimney to figure out the sun's behavior?
In terms of what?
Well, I think we need a spacecraft that flies out this Z field and has instruments where it makes sure that it stays in it, as its trajectory when it reaches, very far away from the sun could be very important to the cosmology of kind of what's going on in our local portion of the galaxy. Also, if you look at things like cosmic ray point sources, right? For instance, a good candidate would be Deneb, the Cygnus X3, right? Mm-hmm. It's a high mass X-ray binary. a quote neutron star, end quote, orbiting a Wolf-Rayet star at some ridiculous periodicity, like 4.83 hours. You know,
Yeah.
it was discovered because of an observatory under a granite mountain in Minnesota, and they said, how come this? It seems like a nuclear weapon's going off constantly and then shutting off every 4.38 hours and then turning 4.83 hours and then turning back on, right? So anyway, so a good candidate for a source of intragalactic protons would be Cygnus X3. It's a thing we know. We're looking down the Z field, which is why it's very hard to figure out the distance to it. You know, it's close enough to measure, I think, with parallax a bit, because it's believed to be what, between 12 and 5,000, 1,200 and 5,000 light years. And also the second strongest radio source in the sky, which just also happens to be in the constellation Cygnus, Cygnus A, the radio galaxy. A very odd thing in that the only object in the sky with a stronger radio source is the sun. And this thing's believed to be 500 million light years away. And yet we get stronger radio signals from that than anything within our own galaxy. An indication that, I don't know how else to put it besides to say that perhaps astrology is more correct than astronomy these days. What say you, Gareth?
Well, I'm not sure about your last statement on astrology. It depends what theory you look at.
I'm just exaggerating to be inflammatory.
Yeah, but I'm not surprised that there are objects out there that emit, you know, high amounts of energy. I mean, if you look at the idea that stars, and particularly the neutron star, you know, if it is an electrical device, then, you know, it depending on the energy that comes into it, it could behave very differently to our sun, where our sun is probably powered at a much lower rate compared to some of those other stars, you know, what we call neutron stars or what we call pulsars. And it probably isn't to do, and I know you're kind of on this Z field thing, but I very much believe that the whole notion of a pulsar isn't because it rotates like a lighthouse.
I agree. That's kind of the classical astronomy stance. It could just be a voltage change, right? It could be flickering because of a change in voltage as opposed to rotation. I believe that's what you're stating, correct?
Yeah, exactly.
Yeah, and this is part of the reason why I like your videos, man, because it seems like we're on the same page when it comes to cosmology and a lot of stuff, and there are not very many people that are on the same page at all when it comes to this stuff nowadays, which is why I find it interesting now, why I got the hell out of cosmology in about 1994. This is why I've been referring to things as massive radio sources since back then, because, you know, I knew what WIMPs were in the mid-90s. And I was like, do I want to get a degree in astronomy and measure Cepheid variables for 20 years for NASA? Nope. So yeah, I appreciate the videos very much. And, you know, I'm trying to get an image of Cygnus A on here. The weird part about Cygnus A is, and, you know, I'm not fixated on Z fields by any means, because Cygnus A, we ain't on the Z field of that thing. We're perpendicular to it. We're on that thing's B field. You know, and I'm quite sure that there are probably structures that are acting as antenna in a lot of cases, and that's why certain things look so weird.
What your definition of an antenna? Because I remember you commented on the video.
Yeah.
But what was your definition of an antenna in that perspective? So something that absorbs it or something that is emitting?
It's going to do everything. It's going to absorb, refract, emit. It should do all of the above. Because if you have just a chaotic structure of plasma and dust and gas sitting around, it's just going to act like a chaotic thing. And while we do see orderly things in the universe, we also see very chaotic things. If you look at just a blob of dust that has nothing but sort of an amoebic appearance to it, the likelihood that it's going to emit any frequency versus any other frequency is pretty much incalculable. But when you see an object, you know, with a massive amount of organization, like an active galactic nucleus, it's a whole nother story. You get to start to try to figure out what's going on, right?
Yeah, but we do know that plasma does interact with radio signals, and this whole idea of plasma redshift comes from that concept of the fact that these, the particles in the plasma absorb and then re-emit the electromagnetic radiation as it passes through.
Sure.
And the same with the Shapiro effect, another thing that you could explain with plasma rather than having to explain it by the curvature of space-time.
Oh, right.
So yeah. I mean, I certainly think that the concept of the fact that there are structures out there in the universe which are made of plasma that we may not be able to see because they may be in dark mode, and that they interfere with or create signals that seem to be something different than they actually are, because they're just, in your words, acting like an antenna. So they're absorbing and then re-emitting and making it appear like something is there when it isn't, even though it is, it's plasma, but it's not, a star or an object like that.
Absolutely. Oh, go on.
So
I didn't want to interrupt. There's a little bit of a lag that happens,
Well, what are we seeing here? I'm trying to work out.
Oh, this is just the Gong 2. We look at this every day on the space weather videos, but usually from the top view ecliptic plane field plot. We usually look at this view. It'll show you stereo A, stereo B, and the Earth. So that data, that's based on about 50 magnetometers on Earth, and then stereo A to the left and stereo B right underneath your Walter White looking face.
Well, not for me, because mine's over there on my screen. But
this is how we're able to actually predict when sunspots will appear. You can if you pour through this stuff all the time, you'll eventually be able to understand, based on these magnetometers, where a sunspot will form. It's a mess. It's not recommended. It's gonna use up a lot of hard drive space in your brain, but it is interesting to understand this. I'm doing this instead of calculating Cepheid variables for 20 years. I'll just do this for 1 year.
With a lot of things, the longer you stare at them, the more likely you are to see a pattern in the data.
Indeed,
and our brains are incredibly good at doing that.
Indeed.
But for me, one of the biggest problems I see in terms of where we are, even if you look within the EU community, is consensus on some of these models, because there are different ideas and concepts for what stars are.
Sure.
For how planets form. Because you were talking about, forming on a string, even like the orbital period of planets, the idea that might be driven by a Birkeland current. But then if you look at the physics behind how those Birkeland currents work, it's difficult to match the exact speed of the planets to, sure, you get close, but it's not quite the same. And then ring formation. Why do some planets have ring and some don't? If we look at some of the images of what they call protoplanetary nebula, then you see ring formation there as well. And admittedly, you don't actually see the planets. You see what they believe is the accretion disk where the planets form from. But what if that's the wrong way around? What if actually what you're seeing is an effect, an electrical effect, that maybe signals that something is about to change inside of the star that might cause a planet to form? And I'm not saying that, because there is the concept of planets forming from stars.
Right.
But then equally, there are sort of hybrid models like Alvin's model, where it was a combination of gravitational accretion and then electrodynamic effects to pull the body together. And there isn't enough evidence to support it. And then the idea that maybe a star is actually a plasmoid. In fact, that it doesn't contain an awful lot of material at all. It's mainly energy and trapped plasma. And maybe it's hollow in the middle.
I think maybe one of the most accurate things to say about a star, or even I'm sure an active galactic nucleus, I think the most reasonable thing to say that it is a magnetic field. It seems like you'd have the most ability to not be wrong. And I try to be a little bit careful. I say some pretty reckless stuff on the channel, but when it comes to science stuff, I'm a real science nerd, so we look like evil versions of each other. Check this out. It's like you've got non-dark glasses, I've got dark glasses. You've got not a lot of hair, I've got a bit. You've got facial hair, I've got none. You're in a light background, I'm in a dark background. This is great. This is just
it's the yin and the yang.
exactly. I assure you, I'm not evil. Now,
it's never black and white. It's always about the grey.
Yeah, I mean,
in between.
I think there's some hybrid stuff going on. It's like, is the sun externally powered or is the sun internally powered? I think that is one of the most crucial questions. If we could figure out the answer to that, the rest of cosmology would probably be a lot more obvious. And I think a lot of models of the universe would vanish overnight, because it would be like equivalent to legalizing drugs and watching the drug cartels vanish overnight. It would just be gone. And I don't want to see astronomers fired because they've been making terrible models for years because they think gravity rules the universe. It's fine. Those models, the data in those models is still relevant to everything else. It's not like you just have to trash all the old science because new science came out. It just needs to be properly applied to what we call cosmology.
Yeah, the problem is, how do you go about detecting that? And that's not easy.
Well,
whether it's internally or externally powered, because even if you look at Alvin's concept, he saw the idea of them almost being like cell-like structures, where so he viewed very much the sun as being powered by itself, so powered and generated by the energy from the gravitational collapse into magnetic energy, and that kind of got used up over time, and the same with galaxies. But they formed like cells, because he saw very much there was a transfer of energy across the boundaries, but no mixing of the stuff from the outside to the inside. Whereas if you look at some of the more current theories, then it is very much that there is a path that leads directly from the galactic Birkeland current down into the solar Birkeland current, which then potentially feeds out to the planets.
Sure.
But again,
I think
we detect this? We're in this great ideas.
Well,
great theories.
maybe we are detecting it, but we're not realizing what we're detecting yet because we're not detecting other things around those things, right? So, for instance, the mechanism, because I'm that guy who, when a new invention comes out, it's like, hey, this thing is magic, and I go, well, what's the physics? If you can't explain the physics, it's not real. So, what if the mechanism that powers the current that powers our solar system is coming out of Cygnus? In other words, the galactic core doesn't really send very much of anything to our solar system. You don't see a lot of radio, you don't see a lot of X-rays. All of the high energy stuff we see, the most luminous object is actually a satellite galaxy quasar, the most luminous object ever imaged. I forget what it's called. It's got one of those catchy names like 4C30274-662. It's like, you can't. Can we please come up with better names for some of these objects? Some of them are kind of important. I mean, we've got the Vela pulsar. That's one that you can actually remember what it is. I'm not memorizing these chunks of numbers though, man. It's not happening. But what if the mechanism that Sagittarius, or even perhaps a neighboring galaxy, for instance, is sending energy to our solar system via the Cygnus arm? There seems to be a lot of stuff coming out of the Cygnus arm of the Milky Way galaxy. I think it needs to be studied in great depth.
But how would that work? How? Because from if the idea that everything scales up, so that we see similar patterns at smaller and then larger and larger scales.
Yes. What are the physics?
How would you explain the fact that a galaxy, which is however many thousands of light years away, is directly plugged into our solar system, which sits within its own galaxy?
Well,
why would
just like you've covered on many of your videos about how these galactic jets, they seem to be, those jets seem to be too energetic to form much of anything like stars until they get sometimes hundreds of millions of light years away from the core of their host galaxy, right?
Yeah.
So if that's the case, the entire
I mean,
the
there's a
entire Milky
finite
Way.
limit, and I can't remember what it is.
Yeah.
There is a finite limit which
But
they believe
it's a lot. It's like it's like 100 million or 150 million light years, I believe, right?
Yeah, it's quite a large distance. Yeah.
So if the distance is that large, I mean, we've got galaxies that are a lot closer to us than that. Perhaps the entire Milky Way galaxy is one of the plasmoids that you're talking about being created by one of these more massive galaxies. In other words, if that's the case, if you were standing right on top of Sagittarius A star, perhaps there's a quasar that's the brightest object in the sky, right?
Mm.
If that's the case, in other words, if the Milky Way galaxy is one of those galactic jet plasmoids where the jet gets far enough away from its host galaxy where it starts to be able to rotate and create sort of a meaningful ionization pathway, that you start to get the Hall effect starts to happen there, and then things start to all form at 90-degree angles to each other. And if that's of course we can't go to Sagittarius A star and see what's going on there, but the fact remains that we may be able to fairly accurately measure the distances of these objects. Of course, being able to measure their output is another story, because when you're looking at a blazar, or even a Seyfert 2 galaxy versus a Seyfert 1 galaxy, it becomes more difficult to calculate the range to it, the distance, as a result of the Z fields, because it's distorting all of the data that you're getting when you're looking at what you would consider the center of this object.
Yeah.
Does that make sense?
But it does, but I would still question if the jet coming out of Cygnus A is that powerful, then surely we would see the effect of that on the surrounding.
Oh no! The jets coming out of Cygnus A. Let me get an image of it. I had an image up here. The jets coming out of Cygnus A are perpendicular. We're looking down Cygnus A's B field. There we go. There's Cygnus A.
Oh right, yeah.
So let me get the large size of this. So like in this case, you've probably got a satellite galaxy forming out here someplace, mm-hmm. right? But if you lived here, this would look like a really bright quasar.
Oh, I see what you're saying.
Because it all comes down to perspective.
Yeah, so effectively, are we a satellite galaxy of Cygnus A?
Right, and within the Milky Way galaxy, are we a satellite solar system to Cygnus X3? That's a really massive object. It's the brightest single object visible to the human eye. We're looking right down at Z field, and it could be 1,200 light years away.
How does that fit in where it is in terms of the movement of galaxies?
That's a good question. And when you think about it, if you try to extrapolate this to the entire galactic rotation, right, this thing has got to be creating a spoke that goes all the way around the galaxy, because it has another Z field that's pointed someplace, but one of its Z field is pointed right at our solar system. So also when you look at it, it has it looks like half of the field is blue shifted and half of the field is red shifted. It's very strange looking when you start studying that particular jet. And the only reason I started studying the jet, that particular thing, is because of the discovery of Göbekli Tepe, actually. It's because the more we look at things like the catastrophe cycle and archaeological stuff, the more we see that things seem to be oriented at the swan. The ancients all say this, the swan is where life came from in the first place. Could that be the progenitor of the entire solar system? If there's a candidate for an object that's sending a proton stream sufficient to form something like the sun, that's a good candidate for it. I know it sounds crazy, but it's not that implausible in my opinion.
But firstly, we're not pointing at we're pointing at the B field. So
yeah, and we're not talking about Cygnus A. This is, can I point? I can't. Can I point? Yeah, I can point there. Cygnus A. That's Cygnus A. We're talking about Cygnus X3, which is Deneb, the star inside our solar system. This is 500 million light years away. Deneb is 1,200 light years away. Well, it could be 1,200. It could be 4,000. And we don't really have good images of it because it just looks like a bright star. Did I lose screen sharing? Is it still?
No, it's still sharing.
Cool. I mean, you know, that's what Deneb looks like. But we do have radio images of it too. And the radio images, there's got to be a spoke that goes around the galaxy coming out of this thing. I don't know if we have. I know I've seen radio images of it. It's a hell of an object, though, man. let's just put it that way. Here's a radio image of Neil deGrasse Tyson. He does not agree with your plasmoid theories, Gareth. Well, I doubt it. Although he probably knows about them by now, because I think there's a lot of astronomers who are shaking in their boots. Anyway, I just wanted to run some of that by you because it's some pretty deep stuff, and we're going to be continuing to study this. I look at the transients on the regs with this thing. You know, it has a pretty consistent periodicity. It doesn't have an 11-year periodicity though, Gareth. I've checked. That would be very odd, and you could say a groundbreaking discovery, right? Oh, I've lost you. Hold on. It's a switch problem. Yeah, I'm still here.
Yeah, don't flick those switches.
I didn't. It just like cut out. It's a CIA, man. They're coming for us. We're gonna figure out the real cosmology, man. They're obfuscating the truth.
What did you say the periodicity of it was?
4.83 hours.
Oh, that's the 4.38 hour one.
Yeah, 4.8.
So that's in terms of its brightness. So it's acting a bit like a. They believe it's a neutron star.
So the Wolf-Rayet star is believed to be a blue supergiant that's about the size of, I believe, Mars's orbit. You know, it's not as big as a star like Betelgeuse, but it's very, very huge, and it's got about a 10 times solar wind density, speed, and heat. And you know, classical cosmologists will tell you that it's being orbited by a thing like a neutron star or an incredibly dense object that's been even termed a quark star. The more you read about this, the less you're going to understand, Gareth. But it's a very, very odd object, and you know, it's part of the summer triangle. It sets every day. I would bet that it has to be one of the cosmic ray point sources. Now, maybe that's getting attenuated by something else, but I mean, this thing was discovered because of a nuclear weapon detector, I believe, is what it was that they installed underneath a 1,000-foot granite mountain in Minnesota, and they said, why are we getting this 4.83 hour signal? How can this be? Is the Russians? It's the Russians, man. They're cosmic ray fluxing us. And then that's like the reason that cosmic rays are, the reason everything is called signets when we start talking about cosmic rays is because of that star. It's because of that star.
That's really bizarre.
It's really strange, man. I mean, and, you know, I'm not blowing smoke up your ass.
Phew. Thank the Lord for that.
I know, that would be a very strange situation. I'd have to have.
I'm just trying to work out. For me, it would be like working out where it is, because the idea that it powers us. Well, I have to admit, I find that that's a strange notion.
It is a strange notion, and it makes this thing even creepier than it already is. I mean, it's fairly evident that this thing is sending protons. You live in the northern hemisphere. It's sending protons through your brain right now, probably. Although I think it's just about setting at where I'm at. It's been set for a while where you are, but it's it requires further study, I'd say. And by the way, I don't have any suicidal notions. If I suddenly am discovered to have hanged myself,
it wasn't you.
Yeah, investigate.
It was the switch you flicked. That's what it is.
Oh, jeez. So anyway, I think this has been very interesting. I do have to get going. I got to be out of here in a half hour to go lead a mountain bike ride. We're gonna feature this later today. This whole conversation. And
random, slightly random conversation.
Well, yeah. I mean, it's. I think there's some interesting science to be done here. And
I mean, I've to be fair, I've not heard of Denem, so it is an interesting one to look at.
Yeah, I mean, if you go to do you know about the Neil Gorell Swift Bat Observatory, the Burst Alert Telescope webpage?
Nope.
So if you're interested in looking at transients, there's a great site that has them all in one place. There's the URL. It's called the Neil Gorell Swift Bat Observatory. And if you go to this place and you type in things like Sig X3. You can also look up Cygnus X1, the famous, quote, black hole, end quote, that was bet on by Stephen Hawking and Carl Sagan, the first accepted black hole. What the hell? I don't see Cygnus X3 all of a sudden. There we go.
No, they've removed it. So.
Yeah, it's already been scrubbed. in the middle of our conversation, before I even made a video. Anyway, there are the transients from it. Don't worry about that missing data there. Everything's got missing data from there. This happens occasionally. And typically they'll try to get it back up. This is from a whole bunch of different radio telescopes around the world, by the way. And the woman who's behind the email address on the main page is very nice. She will respond if you send her an email.
Well, saying the data's missing.
Yeah. Yep. The last time it happened, she said it's missing and we're trying to get it back. And, it's like if you have a power outage in Ecuador, it could cause missing data. Who knows?
Well, I suppose that makes sense. But how do they get it back then?
I don't know. Maybe it could be a situation where their internet went down. Yeah, who knows?
Yeah.
Backup power had to turn on, and then they, didn't have an internet connection or something. But there are the transients from it, and you can look up pretty much any object. Any well-known objects. The stuff that's just been discovered and named you won't find on here, but if you want to look up, the transients for Cygnus A, you just Sig space A. It's got the catchy name of 3C405.0.
Nice. I prefer that much more.
Oh, yeah.
Yeah. It's memorable.
Yeah. I'm going to get this tattooed on
well, hold on. They might change the name. Then you'll be in dire trouble.
Well, it'll still... Those of us who are the true believers in Cygnus A,
we'll have the 3C405.0.
Yeah, we'll start a website called that.
Yeah, T-shirts. Yeah,
only for astronomy elitist jerks. I don't mean to be an elitist, but I am.
And mugs as well. Oh, the possibilities.
But anyway, man, I really appreciate the call. We'll release the whole thing basically just in this form. I mean, the recording kind of just starts up. I guess we'll refrain from calling this a censored versus sinkhole. We'll call this something else, but
fly off the wall.
Yeah, something. Hey, man, there's a sunspot though. Did you see it?
No.
Let's see. Well, there's our thumbnail from today. The thumbnail has a sunspot. Now you're blocking it with your head.
I'm not. You've put me in the way.
Oh.
I'm trying to see the sunspot.
Well, here's the colorized magnetic.
Oh, there it is.
Yeah. It looks like a cycle 24, but it's the polarity is kind of jumbled up, as you can see.
Yeah.
There's something forming down here too, and let's see, that would be cycle 24 behavior as well, unless there's a South Pole field in front of it. Just a plage, it looks like. Anyway, man, I look forward to your next video coming out, and perhaps we can collaborate on Do you think you'd consider making an animation of maybe like the Milky Way on its side, and then zoom into the spiral arm where Deneb is, and the Cygnus arm, and then make an animation of Deneb and the Z field, and how it's pointing right at your head right now, like a insane proton cannon?
Maybe, yeah. I mean, I need to work out where it is.
Yeah.
Because it might be in. I mean, have you got Space Engine?
Oh no, I don't have that. I should get it. I have a pretty good computer. I should actually get it.
Well, I don't know if you can still get the old one. The old one was free. The new one you have to pay for.
Isn't there
It's
a thing
not
called? What about Galaxy Sandbox? I hear the one guy, Anton Petrov, I think it is. I hear him talking about Galaxy Sandbox. That looks like a good one. I haven't tried
I don't know that. I've got Universe Sandbox.
Oh, maybe it's that. I think it's that.
But that's more modeling. And to be fair, the modeling is all based on, yes, you guessed it, gravity.
Gravitational. That's a.
So it has its limitations. Whereas the Space Engine is just everything. It has all the stars in pretty much the correct place.
One last thing. I almost forgot.
Yeah.
Your thoughts on robotized condensed matter is the sun theory?
To be honest, I haven't really studied his model in any detail yet, so
all right.
I don't know.
All right. Well, he just came back. He was on hiatus. He lost his father. He wasn't producing any videos there for a while.
Yeah.
But some interesting stuff, man. Some interesting stuff, and the implications of it are interesting, to say the least.
Yeah, he definitely takes a very different path from the Thunderbolts in terms of explaining the sun.
Well, he's saying here's the spectra we see. Here's how that can exist, and then let's just start from there.
I need to go and look at it because I haven't. To be honest, I saw it. I haven't looked at it.
Look up Sky Scholar. Look up Sky Scholar on YouTube, man. There's so many great videos. I mean, talking about the violations of thermodynamics and
I've seen some of his stuff on Kirchhoff's law and when he talked about the CMBR, stuff like that. I've watched those videos.
Mm-hmm.
But I haven't looked at his sun ones where he talked about his theory.
He's trying to resurrect the Haruni telescope, which is another telescope which would disprove the cosmic microwave background as just noise from things as Z fields and B fields and other radio signals.
Yeah, we just don't know. But yeah, anything.
All right, man. Well, hey, thanks again, and I look forward to seeing your new video. Are you done with it yet? Or are you encoding it now? Or
no. That's the one I'm working on now. Won't come out till Monday, so it's the animations take forever.
I'll bet. Well, anyway, Thanks for making them. I really appreciate it. They are awesome, and we will be watching every one and recommending that our viewers do too.
No worries, dude. Enjoy your bike ride.
Cheers, man. Have fun.
Right,
Not too much. Bye-bye.
Bye.
Ooh.